On this episode of the podcast, I have with me Or Tigley. He is the CTO at MinIO. We're going to be talking about cloud and AI workloads. We're going to walk through some of those infrastructure components of cloud, storage, data protection, operating models and costs. And then we're going to tie back into the AI workloads. So obviously, you're going to need to increase and have an impact to those cloud costs. And we're going to talk about how that is shaping up with Or. And I'm super excited to have you on the show. Thanks for joining.
Thank you so much, Amir. Thanks for having me. Glad to be here.
Absolutely. All right, before we start, obviously you're the CTO, MinIO. What does MinIO do?
Sure. MinIO is a high-performance object storage. It's a distributed object storage. It's S3 compatible, and it's built for large-scale deployments from AI/ML workloads, data lakes, data warehouses, to classical data infrastructure, persistent storage. You can see MinIO everywhere. It's an open-source company. We have written everything in Golang, and it's meant to be very simple from a deployment perspective, and it takes its popularity from that easiness of deployment and use for developers, and from there it grows into large enterprise deployments across the globe.
Let's actually, I'd like to start off with what you just said, open source. It's actually interesting. I've had now a number of guests that have gone the open source path. Talk to us. Tell us why you guys decide that's the right choice for you guys.
So the founder of the company, A.B. Parisamy, and the core engineering team has done this before. They've done a distributed file system, which is kind of the legacy way of building storage systems in 10 years ago. And they have always been true believers of free software. Free software comes from freedom, actually. It's the open source has many debates around it, but we truly believe that the community has the right to use our software with full feature set and everything it's around it. And we believe in the fundamentals of free software and open source, truly. And that's how MinIO is founded on. And we want to provide that to the community. We appreciate our community very much, and the contributions that's given to MinIO is very important for us. And as a result of that, we don't want to go away from those roots, but at the same time, you have to be successful commercially as well. As a result of that, we have decided to have a AGPL v3 type of a dual licensing model. And when enterprises use that, as long as they stick with the AGPL v3 restrictions, we are totally fine with that. But most of them, they don't want to do that, and they come to us from a commercial license perspective. So we believe in freedom of software, free software, essentially, and we also believe in the commercial aspects of that. We are in this to be a commercial entity, so we do both of these. We kind of balance both of them.
Obviously the product itself, and we'll kind of dive in where it sits in some of the views of cloud. Obviously, storage and data protection within your data infrastructure is becoming front and center. I mean, now with everyone wanting to deploy some type of AI solution, that could be, various different levels of maturity, but everyone is now viewing that. Now we're starting to see, not that the concern hasn't been there, it's even more of a concern, but when you're looking at that storage and data protection, and you're looking at your product, and obviously the fact that, being open source has its benefits, when you're looking at some of those dynamics of building more secure software as an infrastructure, how does that open source component fit into that?
I truly think that it's the reverse of the perception in the industry. Open source, by its nature, like just from our example, when we make a release within 3 to 4 hours, we hear from our community right away about a bug, an issue that they've seen. If something is changed, if there's a regression that's introduced, we hear about that immediately within hours. That's totally different than a closed source model where you have to do different stages of QA and testing and give it to a GA release, and then the customer finds out about a security bug or a regular bug or an issue. Open source tends to be much better from that security aspect, in my opinion, because Once you have things, if you look at all of the tools that you use in the industry for security, most of them are open source tools. And that shows how strong is the open source from a security aspect. So I don't have that feeling or the perception that the industry has open source is associated with the security issues and things like that. It's absolutely the wrong impression. What's the issue the industry is trying to articulate is actually is the legacy or the older versions of open source software that's not being taken care of an entity like in MinIO's case. You have a company, you have a dedicated set of engineers who are updating the software. If you don't have that, then yes, you can talk about the security holes and things like that. If you take a release of MinIO from 3-4 years ago, clearly, and then use it in an open source way, in not supported way, it's nothing to do with open source. It's actually not supported. Then, of course, with any software, you may have a problem. If you take a closed source software in not supported fashion, you will have the same problem. Windows 98, it won't have the security things that you need.
Absolutely, and obviously, as we're moving into data being leveraged within different data-intensive applications, right? Obviously, this has been a progress. I think I spoke to somebody who said they view AI as just an extension of software eating the world. It's just the next iteration. It's not a new paradigm, but data at its core has been a challenge when it comes to infrastructure scaling, the speed and access to that data. When you're starting to look at some of those impacts of the cloud and data infrastructure in particular, I guess I'm curious, MinIO or just in general, when you're looking at cloud infrastructure scaling, what are some of the challenges that you see with the rise of AI as the next step of the evolution?
AI is kind of, as you said, is an extension of what we already been seeing with cloud and expansion of data lakes, data warehouses, or the data infrastructure in general. AI is just one of those use cases that's just became quite popular. But at the end of the day, AI needs to do the training and inference. And some of those phases, there are multiple phases clearly in an AI ML kind of a pipeline, but they just generate a lot more checkpoints, a lot more data variations, and in return that multiplies the amount of data that you have to deal with or store in a data persistency model. So we always had a lot of data growth, but with AI it just multiplies because now the amount of data that you need for training is multiplied, and then inference is multiplied, and you're doing different versions of that data, and that's just increases it in dynamically. So we already had the data growth. Now with AI, it's just increasing. And AI being the model that people are using for different projects, all of the generative AI models, we always had different AI models. Predictive AI has always been there for the last 15 years. Generative AI is becoming more and more popular, of course, with ChatGPT in the last couple of years. Both OpenAI, Anthropic, Meta, all of their AI models, they all use object storage, and we are at the center of that. The challenge is with scale, and the scale needs to be addressed with a high performance and very good at scale solutions. And MinIO is addressing exactly that, because MinIO is written in a way that's simple. It can be deployed very easily across commodity hardware, and it can scale infinitely in a theoretical sense. Of course, there is always limits in practical deployments, but in a software way, it can be scaled infinitely. And that's the key here. In order to provide the best infrastructure, you need to keep things simple, grow in an infinite way from a software perspective, and that needs to be high performance. It's easy to do high performance at a small scale in an appliance model, for example, but it's really hard to go horizontal growth and provide really high performance, and MinIO provides that.
High performance, obviously, in the cloud. I mean, typically we start then talking about cost, and obviously, cloud costs are not new. But as we're starting to use larger scale of computing for whatever these data projects that are coming into play, how do you see that cost component?
The cost component, we work with a lot of customers, and in the experience I see with two different enterprises. One is the classical traditional banks, financial services, government, and traditional industries. They don't want to go to cloud because of various reasons. One of them is cost. And the perception is the cost may be okay to store, but it's dramatically much more if you started to replicate, if you start to take out and in data back and forth. The egress cost is well known in the cloud industry, it's the public cloud industry, and that cost can be a variable cost, and large enterprises don't want to deal with that cost. The other aspect of the other type of industries or the enterprises are startups from 10 years ago, 7 years ago, who started in the cloud. They didn't have any on-prem presence, but then their costs started to increase in variable costs. And they don't want to do that on the public cloud, and they want to bring that data on-prem. And they use solutions like MinIO to bring that data on-prem within their four walls using commodity hardware to have fixed costs, lower costs clearly, but also fixed costs rather than having to deal with the egress cost of the public cloud. In our opinion, cloud that is public or private is a cloud. Cloud is not a destination for us. It's more of an operating model that has certain technology components to it. Cloud native architecture, which is microservices, orchestration with tools like Kubernetes, automation of your IT services or operations internally, and scale. At a certain type of a company, you have to have that scale, and you can't really throw people into a problem. You need to scale that with software and automation. And if you have those principles, whether you're building an on-prem solution for data infrastructure with MinIO and other tools that you have with Kubernetes and so on and so forth, or you're using public cloud for certain workloads, it doesn't really matter as long as you stick to those principles. You're just optimizing for different periods of your company's or your product's lifecycle or solutions. Like if you don't have GPUs on-prem and you need to go to cloud for that GPU project, sure, you're optimizing just for that. So it can go both ways, but the cost of that hyperscaler type of approach is always handled best on-prem from the customer experiences we see.
When you're looking at, I guess, deployment, and you mentioned obviously, it doesn't matter where the cloud lives potentially. Do you see any differences in terms of deployment in one versus the other scenario?
Oh, there's definitely differences unless you're truly using a Kubernetes type of a service offering. So what I try to explain is the Kubernetes offering on a public cloud is no difference than a Kubernetes offering on a private cloud that's running a different version. A flavor of Kubernetes running on a private cloud is pretty much the same as a public cloud offering, because Kubernetes is a really nice orchestrator. It's not truly an abstraction layer, but it's a really nice orchestrator that hides all of the complexities. So your software that's written for this containerized approach works pretty much the same on both, but there's still external integration points that is different for different clouds. Doesn't matter public or private. Everybody has a different IDP, identity provider. Everybody has a different encryption software or a solution or KMS. So all those integration points can be challenging. Sometimes it's easy, sometimes it's hard for customers, but those integration points are challenging. Otherwise, public cloud, private cloud, if it's containerized, very few difference that you see from a deployment perspective.
I guess when you're looking at, we're talking a lot about the data infrastructure, the AI workloads, cloud up to now has made a big impact in how software is deployed. Data solutions have always existed, productizing data, that's always been there. But now and again, you please explain to me if I'm wrong, or please kind of go into the depths of it. But as the infrastructure for data is becoming more complex, it's almost becoming similar to what we see for software infrastructures. I mean, you're seeing MLOps, DataOps, that complexity, I guess, in terms of how you see organizations handling their teams, how they are actually setting up. Are you seeing alignment towards a more data-centric infrastructure team? Are you seeing that shared across the infrastructure already in place to support these AI, these larger data projects?
So there is some truth to what you're saying, but it's not at the data persistency layer, in my opinion. The stack above that, which is 2-3 floors above that, is really complex. And the higher you go closer to the user or the application, the end user, basically, that layer is complex from a pipeline, AI ML pipeline, from any kind of a automation pipeline on the cloud. All of that is, there are multiple products, multiple things going on in that layer. But actually, the data persistent layer is going the other way. It's getting simplified. So S3 is the protocol. In 10 years ago, in the data level and in storage world, there were 2-3 protocols in the data center, and public cloud simplified that and made it S3 APIs from an AWS perspective, and Google as well as Azure followed some different variation of that, but they still follow that model. Object storage being the main storage for modern APIs and modern applications. And public cloud made that one. Before on-prem, it was 2-3 different protocols, from CIFS to NFS to Fiber Channel to block to file, different an object. There were 3 different ones. So it's actually getting simplified with cloud, and AI ML is kind of extension of the cloud, because GPUs, limited availability of GPUs in the last 2-3 years because of AI workloads and projects is pushing people to public cloud to a degree. And AI is becoming de facto object storage only type of a storage solution. So opposite of what you just stated, actually the data persistent layer is simplifying with AI ML workloads because of cloud and AI ML workloads specifically for different reasons. But the push is to simplify into object storage, and S3 is the de facto standard on there. But other layers may be a bit more complex. You're correct on that point. But other layers are a little bit detached from the storage layer. Storage layer, I think, is getting simplified, going into object storage as the main storage, and S3 is becoming the de facto standard API there.
That certainly makes sense. I guess if you're looking at storage as getting simplified, and obviously you mentioned APIs, is actually going back a step and maybe looking at it from I guess, larger enterprise view, companies that are looking to implement AI solutions, is the technical feasibility or the technical capabilities becoming a higher bar, or is it becoming a lower bar with more services being rolled out?
Oh, actually, that's a great point, actually. So there was another part of your question, which like investing into the IT teams and how that's changing. So this is also a good segue into that topic as well. Yes, the options and the number of protocols and number of choices are getting simplified, but people who need to deploy that on-prem or in cloud need to be much more aware of these new technologies. They need to be Kubernetes aware. They need to understand the AI workloads or the workflows of AI ML and how they use the S3 protocol or the object storage in an efficient way, how to get higher performance infrastructure deployed in large scale. Those are a little bit more advanced, and you need to have people who are more understanding. The skill set bar goes a little bit higher because they need to be aware of all of these metrics and all of these requirements coming from these new generation applications and workloads. So yes, from that perspective, they need to invest a little bit heavier into those more DevOps, as you said, MLOps, DevOps, and AIOps type of people who understand storage very well at scale and who understand modern storage. Not the classical type of appliance-based storage, because you cannot run AI workloads on a file system or a legacy appliance storage system.
And that's actually a good point. And I guess, as you're mentioning that, I'm thinking you're seeing a lot of companies. I've had guests on that have talked about pilot projects around different AI initiatives. And again, I think AI can be a lot of different things for a lot of different companies. We might be leveraging some machine learning that not even know it. All of those things are true. But as companies are going, hey, we're going to make especially enterprise level, we're going to make a distinct investment. We're going to do some proof of concepts. We're going to run some pilots. We're going to do all these things. And they're actually seeing X costs associated with that. if you're going to see the enterprise adoption increase, and you're going to see companies actually do more and leverage more and bring more in, what happens to the cost? Does it somehow go down based on scale? Is it going to increase because of cloud computing? I mean, obviously, you mentioned storage as a component, and you have all those different factors. What happens as companies start putting more solutions in place?
From an AI perspective, or in general storage perspective?
AI and then storage, because obviously the two are related.
So the AI picture is a bit different. So all the AI training models, they need processing trillions of parameters, and they need the GPU power. Today, it's limited and it's available in certain places, so the workloads shift there. But over the next year or so, the GPU pricing will come down significantly. That's kind of what we think and what we believe. And Intel, AMD, they're seeing this market as a way to, get in there and trying to come up with alternatives, clearly, because that's essential for them, and they will be a player in my opinion. So that's only half of that AI story. The other half of it is the software ecosystem. And the software innovation with GPUs will be accelerated in the next couple of years, and that will bring down that cost. And similar to what cloud has done with multiple players coming in when AWS started, then to Azure and Google becoming, and Oracle becoming, IBM becoming another player, it will have the same impact from a GPU perspective. And then the whole AI higher cost part will be going down in the next couple of years. So that's one aspect of it. It's not only today it's just the dynamics are a little bit in different places. So once that evens out, then that cost will dramatically come down, in my opinion. But they will continue to generate data, and they will continue to have a data persistence layer in different platforms, hence the need for solutions like MinIO getting deployed in different platforms.
Do you see, I guess, as you're seeing companies, I mean, I was on the website in terms of the companies and that use MinIO. It's pretty incredible. I mean, people will link to it. People can see the adoption. Obviously, as your guys are kind of getting feedback with some of these factors of cost, ease of deployment, when it comes to the actual product itself being open source. How does actually feedback come back into the product itself from MinIO perspective, obviously being open source as well?
Yeah, the paid customers are getting direct engineering access through our support. Like we created something called Subnet, a subscription network for MinIO paid customers. We get a commercial license, they get direct access to engineering. So the feedback comes immediately, real time, essentially. If they don't like something, that's something that we need to address right away. And that's been a direct channel to engineering, because we don't have level 1, level 2 support. We don't have layers of people between engineering who wrote the code and the customer. So that's tremendous value for us. And at the end of the day, we are open source. You can take the same features and use it on your small project, but for enterprise customer, that's the business value we provide. And that's critical for them, because they get immediate access to engineering, and there's no feature request, roadmap type discussion going on between different groups and things like that. They literally have something that's not working for them. There's a bug or there's a feature request, that's immediately feedback that we get. So that cycle is very short for us, and we can improve the product tremendously. And if we create other products around that core software, open source software, that's meant to be for enterprise only type of use cases, because we have enterprise using, as I said, encryption software, a KMS, a IDP, that's LDAP, an Active Directory in classical sense, and they need to integrate, they need to have certain controls in their load balancing and things like that. We have all these tools that's going to make their life easier from a large scale enterprise deployment. And that's how we provide them the business value. The core product is at the center of everything. We have the principles of deployment at ease and high scale, high performance at a very large scale. But at the end of the day, they need to integrate this solution with their systems. And everybody has a different choice of a system for external systems, from encryption to authentication and IDP type choices that they made in the past, or logging and monitoring. So we have to integrate all of these and provide the business value that way. So that's what we focus on. And the feedback is direct to engineering, direct to us through our commercial customers.
Awesome work. I mean, I think we keep going. I think you could probably keep answering questions, which is fantastic, but I know you got to get back to it, and thank you for your time. If somebody does want to reach out to you to ask you about MinIO, cloud infrastructure, data infrastructure, AI workloads, what's a good way of getting in touch with you?
I mean, best way is to min.io is our website, and there's different ways of contacting us from there. And just reach out to us, drop a line, or you can just email me, ugur@min.io.
Awesome. Definitely appreciate your time. Thank you very much.
Okay, no problem. Great to be here.
Absolutely. That's it for this episode. Be back again, different guest, different topic. Until then, two things. One, great discussion around cloud, AI workloads, data infrastructures. I mean, this is fantastic. And definitely go check out MinIO. Share the podcast with somebody else that might benefit from it. Also, subscribe, like, comment. Let me know if you want me to cover a different topic. I'll do my best to find a guest to do so. Until next time, thank you and goodbye.